Hey everyone, so today we're going to take a look at our first lesson in our second unit on trigonometry with Pythagorean Theorem. So you might remember this from 8th grade math a little bit. This is going to be our introduction lesson into our study of triangle measurement, which is what trigonometry is. So before we jump into trigonometry, or trig for short, we're going to take a look at Pythagorean Theorem because this is something that we can connect what you've done in the past to what we're about to learn here over the next couple of days. So Pythagorean theorem, again, only works with right triangles. So remember, a right triangle has that little box in the corner of one of the angles telling us, hey, that's 90 degrees. But then we can pick apart the three sides of the triangle. We have A and B, and then C is going to be its own sort of term. But if we take a look at our notes section here, so it's used to find the missing side of a right triangle. So kind of what I was just saying, has to be a right triangle. This does not work on anything other than a right triangle. So, like I was saying before, we have A, B, and C. Well, A and B are what we're going to call the legs of our triangle. And C, hopefully you've heard this word before, hypotenuse. Hypotenuse. And again, for any right triangle, A squared plus B squared should equal C squared. So that is the Pythagorean theorem itself, saying that the two legs squared added together should equal the hypotenuse squared. So we'll take a look at a couple of examples down here at the bottom, and then you guys will get some practice with it. So we look at number one. We have a leg here that's 8 and a leg that's 13. So the first thing you should always do is identify what are you trying to find. So here I'm trying to find x. X here would be my hypotenuse or my C. And the way I can tell that is directly opposite of my right angle is my hypotenuse. And again, hypotenuse is just the longest side of the triangle. So if I set this up, if I start with my Pythagorean theorem, a squared plus b squared equals c squared. Well, from there, we're going to plug in what we know. So we know that 8 and 13 are both my legs, so I can plug those in for A and B. It does not matter which one's which. 8 can be B or 8 can be A, as long as they're the correct parts of the triangle. As long as these are both legs, it does not matter where they go. So I would say 8 squared plus 13 squared equals C squared. And then I'm going to square both of these terms right here. Well, 8 squared, 8 times 8 is 64. 13 times 13 is 169. And that equals C squared. And then I'm going to add these two together. 64 plus 169. And if we put that in a calculator, 64 plus 169, 233. And that equals C squared. So from there, we need to take the square root of both sides. So in order to get C by itself, because right now this is not C, right? That's C squared. So to undo the squaring, I need to come in here and take the square root of both sides. If I square root C squared, that's just going to leave me with C. And then if I take the square root of 233, I get about 15.26, and let's just do to the nearest tenth here, 15.3. So we just use the Pythagorean theorem to find this missing side here. Now you can always think logically, well, does this answer make sense? Well, the hypotenuse is supposed to be the longest side of the triangle, so our answer should have been longer than both 13 and 8, which it was, 15.3. So that seems to be a pretty good answer for us. So let's take a look at number 2. So number 2 here, we have a different oriented triangle here. But again, if I look opposite of my right angle, my hypotenuse is the side I'm trying to find. So here, 22 is a leg, and 27 is also a leg. Again, it does not matter which one's which. I could flip them if I want to. Well, here again, if I start with a squared plus b squared equals c squared, I'm going to plug in both my a and b, which is 22 squared plus 27 squared, and that should equal c squared, or you could also call it x squared because that's what they have it labeled as. And then from there, again, I'm going to square both terms. Again, I don't know what 22 squared off the top of my head is, so I'll just put that in a calculator. That's 484 plus 27 squared, 729. That equals c squared. Again, we're going to add both constants here together. So we got 729 plus 484, and that's a total of 1,213. Equals c squared. And just like we did over here, in order to get c by itself, I need to come in and take the square root. And if I take the square root of both sides, I have to take the square root of 1,213, which is approximately 34.8. 34.8. Which again, if I kind of think about that's supposed to be my hypotenuse, that needs to be longer than both of those sides, which it is. So we're good there. So again, if you kind of look between 1 and 2, the method was exactly the same, right? For the process. Well, I had to square both of my legs, add them together, take the square root, and I ended up with my answer. And that was the same for number 2 as well. So here in a second, we're going to take a look at 3 and 4, where we might not be finding the hypotenuse anymore, but a different side of the triangle, one of the legs. All right, so let's take a look at number 3 now. So 3, I'm trying to find x here, and if I look across from my right angle, I do have that value now. So that's actually going to be my c, or my hypotenuse. Well, 7 must be one of my legs, which I'm going to call a, and x must be my other leg that I'm trying to find, and that's b. So a little different than the last couple, but we're still going to use the Pythagorean theorem, a squared plus b squared equals c squared. Focus for a second. There it goes. So I'm going to fill in what I do know. So a, I called 7, so that's going to be 7 squared. I don't know b, so that's b squared. But I do know my hypotenuse this time, so that's 9 squared. So a little different setup than the ones we did above. But just like the last time, we're going to square everything we can. So 7 squared is 49. We don't know b, so we can't square it, so that stays b squared. And 9 squared, 9 times 9 is 81. So from here, I need to move a term over. So I need to move 59 to the other side by subtracting. And that's going to cancel out my terms there on the left. And then I need to do 81 minus 49, which is 32. So I get b squared equals 32. 81 minus 49 is 32. And then here again, I need to take the square root of both sides, leaving me with 5.656. So if we're rounding to the nearest tenth place, that'd be about 5.7. And again, here we were finding the leg. So I know this needs to be smaller than 9, and 5.7 is indeed smaller than 9. So that missing leg here has to be 5.7, approximately. So a little different process from finding the hypotenuse than when we're finding a leg, but these are the only two things that can happen. You can either find the hypotenuse or you're trying to find a leg. Those are the only two cases that can happen. So your problem's either going to look like this, or it's going to look like this. So let's take a look at number 4 now. So again, 4, I'm trying to find x there. And if I look opposite of my right angle, I do in fact have my hypotenuse. I have a leg, and this leg right here I'm trying to find would be my other leg, or b. So just like all the other ones, I'm going to start with my Pythagorean theorem. A squared plus b squared equals c squared. And I'm going to fill in what I do know. So 19.1 squared plus b squared equals 30.5 squared. Again, just because we have decimals doesn't mean we're going to treat it any differently. But again, I'm going to take 19.1 and sorry about that. 19.1 squared, and we get about 364.81. Let's not round just yet. Let's round when we get our final answer. And then we're going to do 30.5 squared, which is 930.25. So just like the number 3 we did, now we have b squared that we're trying to find, so we need to move this term over by subtracting. Just like that. So we'll take 930.25 minus 364.81. Which means b squared equals 565.4. Take the square root of both sides. Leaving with b equals the square root of 565.43, which is about 23.8 if I round. So, there's 2 examples of finding a missing leg. The 2 that we did at the top, we're finding missing hypotenuses. So those are the only 2 cases that can happen. So now we'll take a look at a couple where we have to kind of dissect the figure and figure out what's what so that we can figure out what we want to know. So let's take a look at number 5 here. So 5, we have this triangle here, and a couple of things we need to know. So if this line is right here, and then we have a line right here, that denotes that, hey, these are the same length. So if this is 24, this is 24. Well, this dotted line or dashed line is cutting this triangle directly in half. So I can think of this area right here, and this length right here, being half of 22. So this would be 11. And if I do that, that then makes this triangle into a right triangle. So if I'm thinking of this triangle right here, if I can find x from this triangle, it's the same thing over there, because again, it's kind of splitting that triangle down in half. So here I'm trying to find a leg. So x is a leg, 24 is the hypotenuse, and the 11 is my leg that I do know. So if we set this up, it's going to look something like this. Again, we're going to start with the Pythagorean theorem. 11 is going to be my leg I do know, so 11 squared, plus the leg I don't know, which is b squared, equals my hypotenuse squared, which is 24 squared. So 11 squared is 121. 24 squared is 576. And again, from here, I need to subtract 121 from both sides, leaving me with b squared equals 455. I will take the square root of both sides. So b squared. Sorry, I had to do the calculation. So b is going to be 21.3. Which again makes sense. It should not be longer than the hypotenuse, which is not, but it's pretty close to being around 22, that range, right? If we got like 2, maybe we had to think, go back and double check it, right? But that seems reasonable, so I know that I probably did my stuff right. So let's take a look at the last 2. So 6. First things first, you look at it and you're like, that's not a triangle, right? But we can do a little modifying to make it into what we want it to be, right? So we can think as if we take a straight line here and kind of cut it like that, right? Well, if this was x, well then this has to be x as well. These would have to be the same length, which would then turn this into a right triangle, which is exactly what we need to do the Pythagorean theorem. So I'm going to write that down real quick, and then we'll label our sides. So again, here across from my right angle I just made, we do in fact have the hypotenuse. We have, oh, sorry, I forgot one thing. So this is no longer 18, right? 18 was the full length. Well, if I just want to know the length of this part, the red part, well, if this was 5, which is this distance here, right? Well, this distance in red would just be 18 minus 5. So this would actually be 13, which would be my A value, or my B, whichever one you want to call it. Well, 13 would be the one I'm working with here, and I'm trying to find X, which would be my B. So 13 squared plus B squared equals 16 squared. Then focus for a second. Maybe. There it goes. So 13 squared is 169 plus B squared equals 16 squared, which I feel like I should know at the top of my head. 256. That's right. 256. Again, subtract 169 from both sides. 169. I get 87. So B squared is equal to 87. But again, that's not our final answer. We need to come through here and take the square root. That should be a little over 9, 9.3. So B equals 9.3. Again, if I look at my side lengths here, sorry. This is 13, was one of my legs. That's pretty close to 13, but it's not larger than my hypotenuse of 16. So I know that that is probably right. All right, so then we're going to take a look at our last one here at the bottom. So our last one is this triangle here, and I want to find out what X is. So I got to do a little thinking here to figure out what is what. so that I can kind of figure out what I'm trying to find. All right, so first off, we're going to work with this smaller right triangle here. Because if that's a right angle, then that's a right angle as well. So we're going to try to find this distance here in red first, which we will call, let's call that A, which we will then use to find this longer side, which we're going to call B. Then we can add them together to find out what X is. So it's going to be kind of two Pythagorean theorem problems in one. So if I'm looking here, again, I still have I have a leg here that I want to find, which is A, and I know that this is 12 my leg, and this is C, or my hypotenuse. So if I set up my Pythagorean theorem, I would have A squared plus 12 squared should be equal to 14 squared. If I simplify that, that'd be A squared plus 144 equals 14 squared, which is 196. You need to subtract 144 from both sides to get A squared equal to 52. Take the square root of both sides to get about 7.2. So I know that this distance here is about 7.2. So we're going to use that to help us find the other part here of B. So make sure you got that down, and then we'll take a look at the other part. Alright, so then let's look at the triangle here, the bigger triangle. Now we're going to call this part here that we don't know B. That's still 12 is our other leg, and now our hypotenuse is 29. So if I set that in, try keeping both in the same picture. Here I'm going to have 12 squared plus B squared. So 12 squared plus this long leg I don't know squared should equal 29 squared. So I should get 144 plus B squared is equal to 29 squared. 29 times 29 is 841. Just subtract 144 from 841. I'm going to get 697. And if I take the square root of both sides, B should equal 26.4. So this distance here is 26.4. So if I want to know the whole distance of X, I'm going to need to add what I got for A and what I got for B together. So my answer is going to be 7.2 plus 26.4 which is going to give me a final answer of 33.6. 33.6. So, if you found this video useful, make sure you like and comment and let me know if you needed help on anything else. But we'll take a deep dive into our next lesson, which will be the introduction to our trig stuff. To where if we can't use Pythagorean theorem, we'll have another way that we can do that. So, hope you guys found something useful here, and I'll see you guys in the next video.